In this video, I'm explaining mathematical expectations of a random variable. See, mean or average value of a random variable taken over all its possible values is called the expected value or expectation of the random variable. So you know that random variable usually it is denoted by capital X, and there are basically two types of random variables: discrete random variables and continuous random variables. Now we are calculating expectations or mean of a random variable when probability distribution is given. See, it is the average value of a random variable taken over all its possible values. For example, a random variable can take n values x1, x2, so on up to xn with the assigned probabilities p1, p2, p3, so on up to pn. That is the probability distribution of the given random variable. Then we have to calculate the expected value or expectation or mean of the random variable. Let us see how to do that. See, when a frequency distribution is given to you, we have seen how you calculate the mean. It is summation fi xi divided by summation of fi. This formula gives you the mean of the given data set. So in the case of probability distribution of a discrete random variable, say discrete random variable's probability distribution is given here. It is like this. x1, x2, so on up to xn are the values of the random variable, and p1, p2, so on up to pn are the probabilities of the random variable. Now, expectation of this random variable is denoted as E of x equal to same as this summation of xi into pi. It is like weighted mean x1 p1 plus x2 p2 so on to xn pn whole divided by summation of pi. We know that in the case of a valid probability distribution, summation of pi equal to 1. That is the condition for discrete probability distribution. So this formula becomes summation of xi into pi I equal to 1 to n. So expectation of a discrete random variable is given by summation of xi into pi I equal to 1 to n, where p1, p2, so on up to pn are the probabilities that you can name it as probability mass function. So in the case of a continuous random variable x, expectation of x is given by integral. Summation is replaced by integral because it is a continuous variable. Summation is for discrete variable. Integral is from minus infinity to infinity over all possible reals. That's why minus infinity to infinity. Xi, instead of xi we have here x, any value in between minus infinity to infinity, into f of x. F of x is the probability density function. In this case, probability mass function, which is nothing but the values of the given random variable at x equal to xi given as a pi. So integral from minus infinity to infinity x into f of x into dx. This gives you expectation of a continuous random variable. Let us see some examples. Find the expectation of number of heads when a coin is tossed twice. So when you toss a coin twice, sample space is HH, HT, TH and TT. So here the random variable is number of heads. So X can take the values 0, 1 and 2. 2 heads, 1 head and no head. We have to find out the mean expectation of number of heads, average of this. X p of x 0, 1, 2. P of x is no head. It is 1 by 4. 1 head ht or th. So 2 by 4. Both heads 1 by 4. So these are the values of P1, P2, P3. Substitute here 0 into 1 by 4 plus 1 into 2 by 4, x1 P1 plus x2 P2 plus x3 P3. 2 into 1 by 4. So this gives you 2 by 4 plus 2 by 4 equal to 1. So expectation of number of heads when you toss a coin twice is equal to 1. See the second problem. For a continuous distribution whose PDF is given by this, you have to find E of x. So it is a continuous random variable. So expectation of x is minus infinity to infinity x into f of x is 3x by 4 into 2 minus x into dx. So, but now the interval here given is 0 to 2. Therefore, for those real values, I have to find out the expectation. So, I can replace these limits by 0 to 2. So, 3x square by 4 into 2 minus x into dx. 3x square because 3x into x, that gives you 3x square. So now let us integrate this. 3 by 4 is a constant. Integral from 0 to 2, x square into 2, 2x square minus x square into x cube into dx. So this is equal to 3 by 4 into integral of 2x square into dx minus 3 by 4 into integral of x cube into dx from 0 to 2. So this is equal to 3 by 4 into 2 into x square integral is x cube by 3 from 0 to 2 minus 3 by 4 into x power 3 integral of x power 4 by 4 from 0 to 2. Let us simplify this. 3 2 ones are 2 2s are 3 ones are 3 ones are. So you will get 1 by 2 into 2 cube is 8 minus lower limit is 0. Similarly, minus 3 by 4 into, so 1 by 4 into 2 to the power 4, that is 16 minus 0. So this cancels with this value. 2 ones are 2 fours are 4 minus 3, that is equal to 1. So in this case also, for a continuous random variable, expectation of that variable is given as 1. So when you perform this random experiment, on an average we will get the value of the random variable as 1. Now let us see some properties of expectation of one-dimensional random variable. So the first property is expectation of k is always k, where k is a constant. Expectation of a mean of a constant is always a same constant. Second property, expectation of kx equal to k into expectation of x. That constant can be taken outside. Then you will get e into x. Third property, e of ax plus b equal to a into e of x plus b, where a and b are constant. It is linearity property with respect to addition. So a can be taken outside using this property. Then e of b is nothing but b. Combining 1 and 2, we will get this third property. Let us apply these properties to this problem. For the following probability distribution, you have to find E of x. So what is E of x? This is a discrete probability distribution. So summation xi into pi, which is equal to, this is xi, this is pi. So minus 2 into 0.15 plus minus 1 into 0.30 plus 0 into 0 plus 1 into 0.30 plus 0.25 into 2.50. Let us simplify this further. This gives you minus 0.3. This is also minus 0.3 plus 0.3 plus 0.5. So these value cancel. These two cancels. Therefore, minus 0.3 plus 0.5, which is equal to 0.20. Similarly, second problem. This is answer for first one. Second one, you have to find out E of 2x plus 3. Apply this property. 2 into E of x plus E of 3 is 3. 2 into E of x, just now we calculated 0.20 plus 3, which is equal to 0.40 plus 3, which is equal to 3.4. Third one, E of x square. So E of x is summation of xi into pi. So E of x square is summation of xi square into pi. No change in pi, just you have to take the square of xi. So minus 2 whole square is 4 into 0.15 plus minus 1 whole square is 1 into 0.30 plus this is anyway 0 plus 1 square is 1 into 0.30 plus this is 2 square is 4 into 0.25. So after simplifying this, we will get the final answer as 2.2. You can check with this. Because this gives you 0.6, this is 0.3, this is 0.3, plus 4 into 0.25, that is 1. So finally the answer is 2.2. See the last one, e of 4x minus 5. We can write this as e of 4x plus of minus 5. So this gives you, use this third property, 4 into e of x plus e of minus 5 is minus 5. So that is nothing but 4 into e of x is, we got it as 0.2 minus 5. So after simplifying this, we will get 0.8 minus 5, which is equal to minus 4.2. So this is the value of e of 4x minus 5. So this is about what is the expectation of a random variable, continuous as well as discrete, and properties of a expectation of a random variable.